Hi, good morning. This is reduction reactions part 2. Today we are discussing about wolf-kishner reduction, Birch reduction, reduction by lindlar catalyst, and reduction by palladium in the presence of charcoal. Let me see that 4 types of reductions in this part 2. First, reduction reactions, wolf-kishner reduction. Wolf-kishner reduction. So it reduces. First, let me discuss about the reagent. For this reduction, the reagent used is NH2 plus glycol plus KOH. This is one of the reagent we can use. Another type of reagent also we can use, that is NH2OH, hydroxylamine. This is hydrogen plus glycol plus base. Mixture is one of the reagent. Hydroxylamine plus glycol plus base, potassium hydroxide. Second type of reagent, and pH, NH, NH2, phenyl hydrazine also we can use at the place of any one of these, glycol plus KOH. These are the 3 types of reagents we can use for reduction of carbonyl compounds under the name wolf-kishner reduction. Clemmensen reduction, it is also one type of reduction in acidic medium, and it is wolf-kishner reduction of carbonyl compounds in basic medium. So what will happen? It reduces carbonyl group C double bond OC that may be present in aldehydes and or you can write anyone and or ketones into CH2, complete C double bond O group convert into CH2. So that is possible. Does not reduce. One more thing, it does not reduce C double bond C group and C triple bond C group. If any group is there along with this, does not touch. Wolf-kishner reduction does not reduce unsaturated double bonds, that is alkene double bond and alkyne, triple bond and double bond. If it is there, it does not touch with that. It only reduces carbonyl group to CH2, aldehydes and ketones to CH2. Finally, they convert into alkanes. So aldehydes, ketones finally convert into alkanes. Let us see the mechanism first. Wolf-kishner reduction means any one of these 3 reagents we can use as a reducing agent, that is hydrogen plus glycol plus base, or hydroxylamine plus glycol plus base, or phenyl hydrazine plus glycol plus base. Any one of these 3 we can use for the reduction, and it reduces carbonyl group that is present in aldehydes and ketones into alkane. C double bond O group converted to CH2, same like that of Clemmensen reduction. But Clemmensen reduction takes place in acidic medium. The reagent for that is ZnHG HCl. But here hydrazine plus glycol does not reduce, and same like that of Clemmensen reduction, it also does not touch with anything. One more point. It is base catalyzed reaction, because we are using KOH now. So base catalyzed reaction. If base catalyzed reaction is there, it forms a nucleophile, a strong nucleophile, a powerful nucleophile. So it is base catalyzed reaction. So if halide is present, in the organic compound along with this carbonyl group, if halide is present, dehydrohalogenation takes place. Dehydrohalogenation takes place if halogen is there. Anyway, in the carbon chain, at any place, if halide means what? Maybe Cl minus, Br minus, I minus. Usually, these will be present as the groups, halide groups. If these are present, B correct, Br minus. So dehydrohalogenation takes place along with the reduction of carbonyl group. If halogen is there, if halogen is not there, there is no issue, there is no thing, there is no discussion. Only it reduces this to this. If halogen is present, definitely dehydrohalogenation takes place. You know, if dehydrohalogenation takes place, it converts into double bond, unsaturated double bond dehydrohalogen. Elimination reaction takes place. It is elimination. If halogen is there, if there is no halogen, nothing, just carbonyl group converting to CH2. So like this, wolf-kishner reduction takes place. Let us see one example. Let me see one example for this. I am taking, where I have to take, so I will take here. Okay, I remove this one. Only this one I am removing. So you have to remember the 3 points. First thing, it reduces carbonyl group to CH2. Second thing, it does not touch double bond and triple bond. Third thing, if halogen is there, that is halide group is there in the carbon compound, in the given compound along with the aldehydes, dehydrohalogenation takes place. The reason, the base is present as a medium, so compulsory nucleophile, strong nucleophile will be formed. That nucleophile acts as eliminating agent, so dehydrohalogenation takes place to form double bond. So example, I use one example, that is Me methyl group 1, 2, 3 and triple bond E is there, and also I am taking double bond O and H. I am taking this group. I am taking all these things. One second, let it here like this. Let it take. So triple bond is there and methyl group is there, and for our sake, let me consider bromine as the present here. Bromine also present. When treated with the wolf-kishner reducing agent, WKR, wolf-kishner reduction, that is any one of these reagents is present. So no doubt this group will convert into CH2. So here we get CH3. So I am writing the product. Me will be as it is, and this group. Then this triple bond will not be disturbed, and then it convert into CH3. Here C double bond OH is there. H is as it is. This will be eliminated and converted to CH2. Total group converted to CH3. And here the bromine is present. Therefore, and here the hydrogen, 2 hydrogens will be there at this carbon. So this hydrogen also will be eliminated, and we get a double bond here. Like this, we get the product. One thing, it reducing this one, and by the base, dehydrohalogenation takes place. I am taking all these things in the same example, and it does not touching triple bond. Double bond, triple bond, if it is there, it does not reduce. So all the points are included in the single reaction. Like this, wolf-kishner reduction takes place. Mechanism, one simple thing, it takes place through the formation of anion of hydrazone. Anion of hydrazone. So mechanism, if you want, I will write. But most of the students, mechanism is not required for this. Clemenceau reduction mechanism is important because there we get carbocation. After that, by the zinc it converted to carbanion. So whenever carbocation is formed, definitely rearrangement takes place. So mechanism is important. Here, anion of hydrazonium and loss of N2 takes place. So no need of that mechanism. And also, if you want to write the mechanism, let me discuss how the reaction takes place. I am writing the mechanism of wolf-kishner reduction. Mechanism of wolf-kishner reduction. First, carbonyl group, C double bond O group, combined with the hydrazine in the kinds of base. The loss of water molecule takes place. The loss of water molecule does not take place by elimination. It takes place by addition followed by elimination. Overall, we call it as substitution. We get C double bond N NH2. This is called what? Hydrazone we get. Hydrazine combined with carbonyl group and forms hydrazone. That hydrazone in the presence of base. When base is present, loss of water molecule takes place, means one of the H will be eliminated. By the loss of water molecule, we get this group, that is C double bond N NH lone pair minus charge will be there. It is anion of hydrazone. Anion of hydrazone. We call it as anion of hydrazone. This will be formed. And this anion of hydrazone undergoes rearrangement. So we get, that is, this will be shift here, this will be shift here. Here the carbon get negative charge and single bond, double bond, NH. Like this we get a rearrangement product. Carbon get negative charge. This one combined with the H2, all are reversible reactions. Please consider all are reversible reactions. Not one is a single step. All are reversible reactions. So what will happen? And loss of H takes place, the H2O on addition, H will be added to that. Means we get the compound like C minus converted to CH, then N double bond NH. And further, once again loss of by the base, once again loss of H2O takes place and we get CH N double bond N lone pair. N double bond, one more hydrogen will be eliminated, and after that, so it convert into CH minus by the loss of N2. It will be formed of one and these electrons will go to here. Once again convert into carbanium. For this, initial H2O is there, na? That will be added to that, and OH minus whatever the base has given, that takes up and convert into CH2. Like this, C double bond group finally convert into CH2 in basic medium. This is the mechanism. The main step in this mechanism is the formation of anion of hydrazone. First, it is forming by the effect of base. So the base should be strong. It will be formed like this. Then protonation takes place. After that, once again anion will be formed. Then loss of N2 takes place. Like this, the mechanism takes place for wolf-kishner reduction. Wolf-kishner reduction. One important thing, not only hydrazine we can use here, we can use semi-carbazine, hydroxylamine, phenylhydrazine, anything we can use. Anything we can use. So same mechanism takes place. Whatever the steps, same mechanism. Like this, wolf-kishner reduction takes place. So in case of Clemmensen, another the variation is what? It is acid catalyzed reaction. So when OH group is there, dehydration takes place. Here, base catalyzed reaction. So if halogen is present, dehydrohalogenation takes place. Dehydrohalogenation takes place. After that, so in reduction reactions, how many are completed? Reduction by nickel in the first video. Reduction by Clemmensen reduction we have completed in the first video itself. Third one is wolf-kishner in this video, and fourth one is Birch reduction. Very, very, very important. But in the question, it will not be there as the Birch reduction. In the question paper, it will not be there as the Birch reduction. So you will give reagent. You have to identify by seeing that reagent. You have to identify immediately if the reagent is there, that is what's the reagent. What is that reagent? Let us see, the reagent for this is any alkali metal, 1A group metal like sodium, potassium, cesium, sometimes rubidium, any one may be there. Any alkali metal, sodium, not lithium. Lithium is non-metallic nature, small size will be there. It is give some side byproduct. So most good alkali metals is sodium, potassium, cesium. in the presence of liquid ammonia. Liquid ammonia. So Na in the presence of liquid ammonia, potassium in the presence of liquid ammonia, or cesium in the presence of liquid ammonia is called Birch reduction. What is the main purpose is means it reduces. Please concentrate everybody. You have to practice like this. The reduction process becomes very easy and most of the organic compounds reductions will be covered here. It reduces alkyne group C triple bond C group 2 C double bond C alkene. Alkyne group convert into alkene group. And here one important, that addition takes place, addition of hydrogens takes place by anti-addition. Anti-addition means what? One hydrogen attaches from this side, another hydrogen attaches to this side. So means, suppose we get like this. One hydrogen will be added here, one hydrogen will be added here. So anti-addition takes place. If we get anti-addition, compulsory the alkene formed is, if anti-addition takes place, the alkene formed is transalkene. It will be trans product, not cis. Cis alkene will be formed by syn addition. Syn addition means what? Addition of two hydrogen groups to unsaturated bond from same side. But here the addition of two hydrogen atoms takes place from opposite sides. Addition of two hydrogens from opposite sides is called anti-addition. In the presence of this, anti-addition takes place. So C triple bond C converting to C double bond C. And one more point, one more variation. It is common. The variation I am saying, the first variation is if terminal double bond is present. Terminal double bond is present in the group, in the given organic compound. If terminal double bond is there, it reduces to single bond. Generally, once the double bond is formed, no further reaction takes place. If that double bond is present between middle of the compound, if the double bond is present yet terminal position, terminal carbon, it convert into single bond. I will get this example. Suppose C, it is M, here triple bond is present and M it is present. So when it is treated with the Birch reduction, so this double bond converting to, this is triple bond converting to double bond like this Me, and here double bond, anti-addition. Anti-addition means what? One double bond here like this it takes place, and here H will be there, then double bond, and this group and H will be there, and like this. Let me calculate the carbon number. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. So we have last one carbon here. So let us do 1, 2, 3. So it will, double bond will be formed, anti-addition takes place. Triple bond converting to double bond, hydrogens are adding in anti-addition. It is transalkene. It is transalkene. Suppose if we have the triple bond like this, M 1, 2, 3, 4. Suppose if you have the triple bond like this, when treated with Birch reduction, 1, 2, 3, 4, 5, 6, 7. Methyl group 1, 2, 3, 4, 5, 6, 7, 6, and double bonds will be there, and 7 like this. 1, 2, 3, 4, 5, 6, 7. One carbon. Take that Me here. like this we get. And here hydrogen takes place. But the reaction will not be stopped here. Further takes place. And ending with the carbon will be ending. So double bond will be formed here. We get the double bond like this, hydrogen only, and here on the right it will be there like this. 1, 2, 3, 4, 5, 6, 7. And the reaction, further reduction takes place because double bond is there at final position. So it convert into methyl group 1, 2, 3, 4, 5, 6, 7 methyl group. We get alkane final. Alkene. Why here the reaction is not stopping at alkene position means the double bond is not the middle, it is there at a terminal position. So like this, you have to observe the terminal positions. This is one variation. First thing, Birch reduction takes place by this reducing agent. It reduces C triple bond C to C double bond C. The addition takes place by anti-addition, and that too, if double bond is present at terminal carbon, further reduction takes place to alkenes. If double bond is not at terminal position, the reaction will be stopped there. So like this takes place. This first variation. The second variation in this is, it also reduces aromatic compounds. The second variation, very important it is. Second variation is, it also reduces aromatic compounds. Reduces aromatic compounds. Very, very important. Previous examinations we have this reaction. You can check previous papers. In that papers it was there. So please see, it also reduces aromatic compounds. Two isolated double bonds. Isolated double bonds. How? Let me see one example. It also reduces aromatic compounds to isolated double bonds compounds. Suppose if you take benzene, when treated with Birch reducing agent, sodium in the presence of liquid ammonia or potassium in the presence of liquid ammonia, Cesium in the presence of liquid ammonia, we get this product, isolated double bond, cyclohexa 1,3 diene, we get like that. So means aromatic compounds converting into alicyclic compounds with double bonds. And number 3, third variation in Birch reduction is, if electron withdrawing groups are present, or one, let me take one example, electron withdrawing group is present, I am writing shortcut EWG, electron withdrawing group. It takes electrons from benzene ring. If electron withdrawing group is present on benzene ring, by the Birch reduction, the product formed is isolated double bond product with the allylic position of electron withdrawing group. The product formed is isolated double bond product with the electron withdrawing group, yet allylic position to both double bonds. And second I am saying, if electron withdrawing group is present on the benzene ring, by the reduction of Birch reduction, the product formed is isolated double bond product with electron withdrawing group in allylic position to both double bonds. How means? I am taking this one only as an example. Please see. Suppose if COOH group is there, the best electron withdrawing group is there, COOH group is there, by the Birch reduction, first it forms an anion radical Anion radical means like this it forms double bond O, OH, and 2 electrons will be there here. By that it is charged, double bond, and here radical takes place. Like this it forms intermediate, stable intermediate. This stable intermediate undergoes rearrangement like this. How it is undergoes rearrangement? So benzene ring, double bonds, radical, and double bond C, O minus OH. By shifting of this one here, by forming this minus here double bond. So like this it forms, and then it gives a product. It gives a product like this: benzene ring, double bond, and COOH. Allylic electron withdrawing group is present at allylic position to this double bond, allylic position to this double bond. Like this, if electron withdrawing group is there, we get the product like this. Is important. Variation is important. Everybody know what is the reduction. Sodium, the presence of liquid ammonia, compressed reduction takes place. Everybody, it is anti-addition, just extra thing. But these things are important. If electron withdrawing group is present on the benzene ring, it takes place like this. Next, number 4. If electron donating group is present on the benzene ring instead of electron withdrawing group, if electron donating group is present on the benzene ring, so it gives isolated double bond product with the electron donating group, which gives electron donating group, yet double bond end position, yet double bond end position, double bond end position. I'll write example. I'll write here itself. Okay, I'm taking new one. So how means, suppose this is benzene and here CH3 group is there. A best example of electron donating. When it treated with Birch reduction, it forms anion radical. It is called anionic radical. Here also anionic radical will be formed. That anionic radical is this one, stable anionic radical. How means double bonds here as it is. Double bonds will be changed, not like this. Here double bond, and CH3 group is here. CH3 group is here, and here we get minus charge with anion, and here radical. This is intermediate we get. This forms a product like this: double bond, CH3. Different. Here it is allylic position, here double bond ending position. Like this. If electron donating group is there, this is the product. If electron withdrawing group is there, this is the product takes place by the Birch reduction. This is very, very, very important by the Birch reduction. And one more thing. If electron withdrawing group is there, this is electron withdrawing group now. If electron withdrawing group is there, reactivity increases. Please remember this. If the question is coming based on reactivity order for reduction, if electron withdrawing group is there on the benzene ring, reactivity increases. If electron donating group is there, reactivity decreases. Reason, the formation of this is tough as compared to formation of this. Simple. Reactivity increases if intermediate is more stable. Reactivity decreases if intermediate is less stable. The formation of intermediate depends on the reactivity. If the reactivity is more, that is reactivity depends upon the formation of intermediate. I'm sorry, this variation. If intermediate is forming easily, because if it is stable, the reaction takes place easily. If the intermediate formation is not easy, so reaction takes place slow. So like this, reactivity takes place. This is Birch reduction. fourth one. So we have completed two reductions in this video. One is wolf-kishner reduction, another one is Birch reduction with the variations. Compulsory is important. In the examination, he will not ask the name of the scientist. He will give just reagent. Based on the reagent, you have to identify what type of reaction takes place. If you are identifying the type of reaction, automatically you can easily get the answer. So next, fourth completed. Now, fifth reduction is, I told you total 18 reduction reactions are there. If you know that 18 reduction reactions, compulsory one question you can solve. Damn sure, compulsory one question you can solve. So in that 18, fifth reaction, that is Lindlar's catalyst. In this only we get Rosenmund reduction. But at what time we have to consider it as Rosenmund reduction? Let me say. So Lindlar's catalyst. Reduction by Lindlar's catalyst. It is also takes place. It also reduces. So it is also reduction. Lindlar catalyst also reduces. What is the reagent of Lindlar's catalyst? First let me write. What is the reagent of Lindlar's catalyst? It is hydrogen in the presence of finely divided palladium plus sulfur or quinoline. You can use any one. Sulfur in some books it is there as sulfur. In some reactions it will be there as quinoline. Any one we can use. H2 plus finely divided palladium. Yes, and quinoline in xylene medium. It acts as a poison for this palladium. S or quinoline acts as a poison for palladium catalyst. So this is reagent. Once again I am saying hydrogen plus finely divided palladium plus sulfur or quinoline xylene medium. Xylene medium is the reagent of Lindlar's catalyst. Boiling xylene also means. What is the purpose of this? Means it reduces alkyne group C triple bond C group 2 C double bond C group by syn addition. In case of Birch reduction, C triple bond C converted to C double bond C by anti-addition. So it is giving trans-alkene. But here, reduction takes place. C triple bond C converted to C double bond C by syn addition. Due to this syn addition, what type of alkene we get? Due to this, cis alkenes are formed. In case of Birch reaction, means sodium in the presence of liquid ammonia, anti-addition takes place and it gives trans alkenes. But here, syn addition takes place. See, let us see. Example: methyl group 1, 2, 3 double bond, triple bond is there, and like this it is there. 1, 2, 3, 4, 5, 6, 7. When treated with the Lindlar's catalyst, I am writing shortcut LC. Any, all of these things should be there. But either sulfur or quinoline, any one will be there. So it gives methyl group 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Right. Double bond will be here. 1, 2, 3. Third by 1, 2, 3. Here double bond will be there. But the product is like this. Cis product. Because hydrogen will be added here, hydrogen will be added here. This is a product we get. This is cis alkene we get. Cis alkene. Because syn addition takes. Syn addition means what? 2 hydrogens will be added to the triple bond from same side. In case of anti-addition, one hydrogen taken place from one side and another hydrogen taking place from opposite side to the triple bond. That's why it is anti-addition, but it is syn addition like this takes place. And here the variation is in Lindlar's catalyst. The variation is if acid chloride group is present. Acid chloride group is present. If acid chloride group is present, it also reduces that. Lindlar catalyst, right? Lindlar catalyst also reduces that group 2. Reduces that group 2 aldehydes. In the group, if acid chloride group is there, ROCl, acid chloride group is what? C double bond OCl. If this group is there, or you can no need to write this one. We can write like this. COCl group if it is there, it is Lindlar catalyst reduces that group to aldehyde, means it converts into CH. The conversion of acid chloride to aldehyde is called what? Rosenmund reduction. Rosenmund reduction. So Lindlar catalyst nothing but if acid chloride if it is there, it converts into aldehydes. That conversion is called Rosenmund reduction. So it is another scientist name here covered. Rosenmund reduction means if it is present, or else normal reaction takes place. This is Lindlar. Rosenmund catalyst. If I write the reaction for this one, by considering all these things, 1, 2, 3, 4, 1, 2, triple bond, double bond, Cl if it is there like this. When it treated with the Lindlar catalyst, what is the product we can expect? Please write down. If you can write down, then I write the product. Please try. When this group, this compound treated with the Lindlar's catalyst, what is the product we can expect? The product is 1, 2, 3, 1, 2, 1, 2, 3, 4. How many carbons are there? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So that double bond will convert into H, and here we get syn addition. Syn addition means double bond at the which carbon it is? 1, 2, 3, 4. 1, 2, 3, fourth carbon, fourth, 1, 2, 3, 4, right. So we get like this. 1, 2, 3, 4, 5, 6, 7, 8. So we get double bond of this. This is the product. If this group is there, we get this. Sorry, it's not dots. We will consider these are the dots. So while writing, we got the dots. So this is the product. Next and last reduction in this is sixth reduction. Reduction by, out of 18 I am saying sixth. Reduction by H2 plus palladium plus coke. That is charcoal. The reduction takes place by this one. Reduction by hydrogen, palladium, charcoal. It is not poison. Due to this, what will happen? This reagent reduces. Double bond alkene to alkane. Alkene to alkane. It reduces. Direct alkane will be formed. This is one. Number two, if any nitroalkane is there, it convert into amine, primary amine. Nitro group convert into primary amine when treated with this. Number three, if cyanide is there, C triple bond N, By this one it convert into CH2 NH2, primary amine once again. Primary amine. If fourth one, azide is there, N3 if it is there, it convert into NH2, primary amine. Azide also convert into primary amine. And fifth one, 1, 2, 3, 4, fifth one. If benzyl alcohol is there, specialties, not all alcohol, only benzyl alcohol. Is benzyl alcohol. When treated with this reagent, H2 plus PD plus C, it convert into toluene. The specialties, benzyl group compulsory. If benzyl group is attached, is present to ONS, only this reaction takes place. If benzyl group is attached to ONS, like benzyl group attached to O, so like that ONS, if attached to benzyl group, this reaction takes place. It cannot into toluene. If it is not there, there is no benzyl group, there is no oxygen, nitrogen, sulfur, no reaction. Compulsory should be benzyl, there should be either oxygen or nitrogen, sulfur. Then by this it converts into toluene. If no benzyl, reaction. No oxygen, nitrogen, sulfur, no reduction. So like this, reductions takes place. This is the part 2 video of reduction reactions. Total 18, now completed 6. 12 more are pending.